Welcome back to Refreshing Careers. Today we'll be doing the part 7 of linear programming, and today we are going to solve another question. The question is, vitamins A and B are found in foods F1 and F2. 1 unit of F1 contains 3 units of vitamin A and 4 units of vitamin B. 1 unit of F2 contains 6 units of vitamin A and 3 units of vitamin B. 1 unit of F1 and F2 cost rupees 4 and rupees 5 respectively. The minimum daily requirement for a person of vitamin A and vitamin B is 80 and 100 units. Find out the optimum mixture of foods F1 and F2 at minimum cost. Okay, at minimum cost, which means the daily requirement of vitamin A and vitamin B. Formulate an LPP. So here they have asked us to formulate an LPP. So we need not solve the problem, you have to only formulate an LPP. So here what you can see is they have told that we have to buy 2 foods, and the food is F1 and F2. This is the name given to the food. Okay, in F1 there is vitamin A in the given combination, and in F2 there is vitamin A and B in the given combination. In F1 F2 basically there is A and B in the combination that's given over here, and the cost of F1, that is for every unit of food 1 that you buy, the cost is rupees 4, and for every unit of F2 the cost is rupees 5. So the cost of it is given, and this is your constraint. Find out the optimum mixture of foods F1 and F2 at minimum cost, which meets the daily requirements of vitamin A and vitamin B. So basically we have to purchase F1 and F2. They are asking us to purchase F1 and F2, and we have to purchase F1 and F2 keeping in mind that there is the required quantities of vitamin A and vitamin B. Okay, and also we have to make sure that the cost is minimum. See, whenever we are going to purchase something, okay, we'll try to reduce the cost as much as possible, right? So even here also, when you're going to do something and you're going to purchase food, we'll try to ensure that we would buy it at the least cost possible, as least as possible. Okay, and when you are doing that, we'll not be sacrificing our requirements. Our requirement of 80 and 100 units of vitamin A and B, that should not be sacrificed. So we will have to keep this in mind and find the optimal quantity of F1 and F2 that needs to be purchased. They have told the cost of per unit of F1 and F2, but they have not told how much quantities we need to buy of F1 and F2. That is what we need to find out. We need to find out what is the optimal mixtures of F1 and F2. We need to find out how much of F1 should we buy and how much of F2 should we buy, so that the cost is minimum and all the requirements of vitamin A and vitamin B also are met. So this is what we need to do in this question. Now let's go to the objective part. The first thing that we need to find or solve is the objective function. Now what is the objective over here? We are purchasing something, right? We are going to purchase food. So we have to ensure that the cost is minimum over here. When we are purchasing, we have to ensure that the cost is minimum. Okay, and even in the question I mentioned the minimum cost. So we can understand the function here is to minimize. We have to minimize. So objective is to minimize the cost. Okay, so the objective function. The objective is to minimize cost of F1 and F2. Okay, our objective is to minimize the cost of F1 and F2. And let us assume the total cost to be as Z. We are assuming total cost to be as Z because it's not given in the question. Total cost will be equal to cost of F1 plus cost of F2. So total cost is nothing but the cost of purchasing your F1 and the cost of purchasing your F2. This is simple. Now what is the cost of F1? Cost of F1 is the total units of F1. Okay, the total units of F1 that you are going to purchase multiplied by the cost per unit of F1. That will be your cost of F1. What's the cost of F2? Cost of F2 will be total units of F2 that you are going to purchase multiplied by cost per unit of F2. That is the cost of F2. So now cost per unit of F1 and cost per unit of F2 is given in the question. that is given over here. 1 unit of F1 and F2 cost rupees 4 and rupees 5. So when we know the cost per unit of F1 is 4, cost per unit of F2 is 5. Total units of F1 is unknown, total units of F2 is unknown, so we will be taking it as x1 and x2. So we will be assuming that x1 is the total units of F1 and we will assume x2 to be the total units of F2. And this x1 and x2 are called as the decision variables. They become the decision variables, and the equation will be z is equal to x1 into 4 plus x2 into 5, where x1 is the total units of F1 multiplied by the price per unit of F1 plus total units of F2 multiplied by cost per unit of F2. So this is your objective function. So once you're done with the objective function, the next thing is to find out your constraint. Now the question they're given that the minimum daily requirement of vitamin A and B is 80 and 100 units. So minimum of vitamin A, how much we should have an intake of? 80 units. Minimum 80 units should be our intake of vitamin A. Minimum 100 units should be our intake of vitamin B. That's what they have told. So we have written it as 80 and 100 units. So vitamin A maximum, minimum 80. Vitamin B minimum 100. Okay, it can be above 80, it can be above 100, it can be equal to 80, it can be equal to 100, but it should not exceed. Okay, it is minimum. Okay, it's minimum. And now the next thing that we know is, which we are told is, in food 1, 3 units of vitamin A is there. In F2, 6 units of vitamin A is there. Okay, in F1 there are 3 units of vitamin A. In F2 there are 6 units of vitamin A, and totally they have said that minimum there has to be 80 units of vitamin A, and they said that there has to be 80 units of vitamin A. Okay, so based on this we have to formulate the constraint for vitamin A. We need to formulate the constraint for vitamin A. 3, 6 and 80. Keep this in mind and let's solve this. 3x1 plus 6x2 greater than or equal to 80. That is, 3x1 plus 6x2 is the total vitamin A intake. 3x1 plus 6x2 is the total vitamin A intake, and this total vitamin A intake has to be greater than 80 or has to be equal to 80. That is what this thing is saying. 3 is your, as we saw here, 3 is the units of vitamin A in F1 multiplied by the total units of F1. Okay, that's what we're doing over here. Okay, 3 is the vitamin A present in F1. Okay, 3 is the vitamin A present in F1 multiplied by number of units of F1 that we are going to purchase. So 3 is with respect to 1 unit of F1, right? So we need to find out with respect to all the units of F1 that we are going to purchase. That's why we have done 3x1 plus 6x2. 6 is the same thing. Vitamin A present in food 2, that is F2. Vitamin A present in F2 multiplied by number of units of F2, that is 6 is with respect to 1 unit. Okay, 6 is with respect to 1 unit of F1, but we don't know how many units we are going to purchase. That is x2. So we assume it to be x2, and then we multiply this, and this entire thing tells us the total vitamin A intake. Okay, the total represents the vitamin A intake, and the total vitamin A intake has to be greater than 80 or can be equal than 80. That is what this means. Now similarly, there is vitamin B constraint. Here they have told that there are 4 units of vitamin B in food 1, and there are 3 units of vitamin B in food 2, and they have told minimum 100 units, and they have told minimum there has to be 100 units. Okay, so we have to keep this in mind and formulate a constraint with respect to vitamin B. Okay, 4x1 plus 3x2 has to be greater than 100 or this has to be equal to 100. That means this is the total, okay, this is the total intake. This is the total intake of vitamin B. And the total intake of vitamin B can be equal to 100 or can be greater than 100, because what they have told us that the minimum requirement is 100. So it can be equal to 100 or greater than 100. And 4 is similarly like how I told for this. 4 is the vitamin B that is there in F1. 4 is the vitamin B that is there in the that's there in 1 unit of F1, that has to be multiplied by the number of units of F1. 3 is the vitamin B present in 1 unit of F2. Okay, this is with respect to 1 unit of F2. We don't know how many units of F2 are there, which we have assumed it to be as X2. So we multiply this 3 with the number of units of X2. That becomes 3x2. So this becomes the total intake of vitamin B. And this total intake of vitamin B has to be greater than 100 or can be equal to 100. This is the constraint with respect to vitamin B. Now the next one is very easy. This is the non-negativity condition. Here this is nothing but it can be positive, it can be positive, it can be 0, but it should not be negative. That is a decision variable, should never be negative. It can be greater than 0, it can be equal to 0. That's what they are saying. Here x1 and x2 is the total types of there's the total units of F1 and F2, right? Now when you are purchasing food 1 and food 2, it can be equal to 1, 2, 3, 4 such positive numbers, but you cannot have a purchase of minus F1 food. How can you purchase food in minus? You can't. Either you are not purchasing food, that is 0, or you purchase something and that will be in a positive quantity. That will be a positive numerical. That's why it is like this. That's why x1 will always be greater than 0 or will be equal to 0, greater than 0 or it will be equal to 0. Now we have to write down everything together. The LPP can be formulated as follows. Your total cost, that is minimize Z. Okay, you have to minimize Z, which is equal to minimum Z is equal to x1 into 4 plus x2 into 5. x1 into 4 plus x2 into 5. x1 into 4 plus x2 into 5. Subject to certain constraints. Okay, subject to certain constraints which are 3x1 plus 6x2 greater than equal to 80. 3x1 plus 6x2 greater than or equal to 80. 3x1 plus 6x2 greater than or equal to 80. And the next one is 4x1 plus 3x2 greater than or equal to 100. 4x1 plus 3x2 plus 3x2 greater than or equal to 100. And then a non-negativity condition. That is x1 is greater than or equal to 0, x2 is greater than or equal to 0. Thank you so much. Please do like and subscribe it. Thank you so much. Please do like the channel and subscribe the video.